So let's do a very common example that involves using the laws of motion. So let's begin. So as shown in the diagram to your right, block number 1 with mass 1 is connected by a massless rope to block number 2 with mass 2, which hangs vertically downward. Suppose that mass number 1 is 20 kilograms and mass number 2 is 15 kilograms. Assuming a frictionless surface on which our mass number 1 is traveling and assuming a frictionless pulley, find the acceleration of the masses. So this mass will pull down on mass number 1 and it will create an acceleration. So this will go down with some acceleration and this will move to the right with some acceleration. Now their magnitude will be the same, but directions obviously are going to be different. This mass will be traveling along the horizontal axis and this mass will be traveling along the y-axis, the vertical axis. So before we begin, let's make the assumption that this is our x-axis and anything going this way is positive, anything going this way is negative. And let this line, this axis, be our y-axis. So anything going up is negative, anything going down is positive. So we're going to use the second law of motion, which will help us find all the forces acting on this object and then all the forces acting on this object. So let's begin with mass number 1, our block number 1. We want to find all the forces acting horizontally along the x-axis on mass number 1. So since we're assuming this surface is frictionless, there's only one force acting on our object, and that's the force due to the tension in the rope that's created by this mass number 2. So let's write the sum of all the forces along the x-axis acting on mass number 1 is equal to simply our force of tension, which in this case is positive because we're assuming that our x in this direction is positive. So equals the mass of 1, the mass of block number 1, multiplied by its acceleration. So force equals m times a from the second law of motion. So now let's do exactly the same thing but for block number 2. Now we're looking at mass number 2 and we're looking along the y-axis, the vertical axis. So let's look at all the forces acting on our mass number 2. Well, here we have two forces. One force pulls down and that's the force of gravity. The other force pulls up and that's the force of our tension in the rope created by this mass number 1. Now, going down is positive, going up is negative. That was our assumption. So our force of gravity is positive, our tension of rope is negative. So the sum of all the forces acting along the y-axis on mass number 2 is equal to the force of gravity, m2 times g, minus the force in the rope, the tension, equals mass number 2 times our acceleration of mass number 2. So now we have two equations and two unknowns. We don't know what our force in the rope is, our tension, so we don't know these guys, and we don't know our accelerations. So what we can do is simply take this value and plug it in for this tension. Because we're making the assumption that this rope is in fact massless, that means whatever force of tension we get here, the magnitude is the same up here. So that means this Ft and this Ft are exactly the same. So I can take this guy and plug it into this Ft. That's exactly what I do. So let's rewrite this equation, put it down here, but now we're rewriting this as this guy. So m subscript 2 times g minus m subscript 1 times a equals this guy, m subscript 2 times a. Now let's bring all the a's, all our unknowns, to the right side. So let's add this guy to this side and we get m subscript 2 times g equals this guy plus this guy. So the mass of 2 times a plus the mass of 1 times a. Now notice that a appears on this side and on this side, so let's take it out. Here we take it out, and now let's take this guy and divide it here. So we get our acceleration is equal to all our knowns. Mass of 2 times g divided by the total mass of our system. And we simply take our values, plug them into our equation, and we get 15 times 9.81 divided by 25, or 35. and we get 4.2 meters per second. So this is our acceleration, the magnitude going downward as well as traveling this way. The direction, however, in this case is going vertically downward, in this case it's going horizontally to the right. Now, if we want to find the force in the rope, we can do exactly that, because now we know our acceleration, which is 4.2, and we know the mass 1, which is simply 20 kilograms. We plug that in, and we'll find our tension in the rope.